Okay, people watching the recording, I am using this simulation. I got it. I'm going to get it to, in fact, I'm going to hit refresh. I'm at 1 atmosphere. I'm going to cool this down to 100 Kelvin or close. There we go. That's number 2. I got 100 Kelvin. Number 2 is 100 Kelvin. Now the volume is 246 liters. That's number 3, 246 liters. And then we doubled the temperature. So I hit the heat, and I'm just going to say pretend here. And I got it to 200 Kelvin. I'm pointing with the arrow, 200 Kelvin, and the new volume was 492 on number 5, 492 liters. Which means on number 5, new volume over old volume gives me 492 over 246, meaning that the volume increased by a factor of 2. So we increased the temperature by a factor of 2. We doubled it. And then the volume increased by a factor of 2. Then we said, pump in more molecules, 6, and the pressure and the temperature will do what? The pressure and the volume, excuse me. And first the volume goes up, and then when we run out of more volume, the pressure goes up. So they both increased, and that's where we got to before I remembered to hit record. So they both increase. Then on number 7, pick some beginning measurements. Let's just fool around with this. I'll decrease this so that I have some room to work and maybe let out some pressure. And we'll heat that up. Make the pressure go, the volume go up, and then maybe let out some molecules and increase that and heat that. Honestly, I'm just getting a bunch of random stuff. Whoops. That's not what I meant. Not that much. Okay, I just stopped at a place. I don't care. Beginning measurements. Number 7 are, put in the liters, Kelvin, temperature, and atmospheres. Liters, 389. Kelvin, 330. And atmospheres, 4.17. Increase the volume. And what's the ending volume? Sure. 739. By what factor did the volume increase? So we do new over old, which is 739 over 389. And then can someone actually type that in? Because I really did that at random and I don't know the factor of increase. Come on. Anybody 1.89? Okay, 1.89. Note the ending pressure. The ending pressure is 2.2 atmospheres. So what was the ratio of the pressure change to new over old? And it's not big over small, it's new over old. So it's 2.20 over 4.17. Anybody? 0.53? we see if the temperature stayed the same, as the volume, we increased it, right? The pressure decreased, right? And then it gets even more interesting. 13. Here's an interesting point. Divide 1 by your answer to number 11 and compare the new answer to number 9. 1 over the answer from number 11 is what? Somebody type it in for real. What's the next digit? 8. What's the next digit? 1.89. Trying to disprove my point. Aha, said all the math people. The math what? There's a method, yes. So that's just one way of saying, you know what you have there is we had 1.89, and then when you get 0.53, that's the like flip version of 1.89 in a sense. When we take one over a number, like having 1 over 5 instead of 5, we have anybody know the math term here? If you flip it.
Inverse.
Yeah,
reciprocal math.
Okay, you're right. The reciprocal would work too. I was hoping somebody would say inverse because that lets me use that same word for 15. This shows us that if the temperature stays the same, volume and pressure are inverse what? Anybody know? Well, they sort of are proportional, but they're not directly proportional. They're giant clues being dropped here. Boom, boom, boom. They're what?
Inversely proportional.
They're inversely proportional, which is a great phrase for you to go off to college with. And you can say, oh, yes, I see these are inversely proportional. And you will look all educated and stuff. So just to drive this home, if this had been 2, what would this number have been?
0.5.
Yeah, half, huh? If this had been 5, this would have been 1/5. If this had been 4, this would have been 1/4. Hmm? So wait, you're saying if the top one was 5, the top one would be 1/5. Yeah. So if it was whatever. It's 1 over. That's inversely proportional. Means if this one gets multiplied by 10, that one becomes 1/10. Here, trying to think of examples here. Using the bottom of my paper as a scratch paper again. Let's see, A equals 1 over B. Well, that means that we could say 5 equals, well, and this is going to get a little mathy here, but I got some mathy people. What is B? It's 1 over 5, because what is 1 over 1 over 5? One over 0.20 or 100 over 20. Same thing, which is, guess what? 5. How many 20s can you cram into 100? 5. What's 100 over 20? 5. How many 0.2s can you cram into 1? 5. So what's 1 over 1/5? 5. If this gets bigger, this must get Smaller.
So let's say A is 1,300.
Oh boy. Nathan says, what if A is 1,300?
I mean, it would be
1 over.
1 over 1,300.
No, 1 over 1,300. Like that. Oh, okay. That is what you meant. Okay. Because in fact, a kid surprised me in 4th period today. And on the next sheet, he decided to kind of go the whole lap around the track just to get to the starting point kind of thing. And he ended up taking the inverse of the inverse, which is how you get back to the regular number. If you take the opposite of the opposite kind of thing, that's kind of what we're doing here as a concept. You get back to where you started. So the inverse of the inverse is that number. Or equals 1 over 1, isn't that 1? How do you divide by a fraction? You multiply by the reciprocal. So this really is that. If you, for all my math people out there, that's the 6th grade version of doing that, isn't it? And so what do you get? 1,300. That's what I said. The inverse of the inverse gets you back to the number. Ta-da! Okay, so repeat with gas B. It says on 16. I'm going to turn off A and turn on B. Oh, I forgot to share it. Pick and note some beginning measurements, number 17. So I'm just going to pick some stuff. Oop. I forgot that I keep forgetting it coasts. Or you know what? Okay, random numbers. What do we have? Let's put them in for number 17. 443 liters, 385 Kelvin, and 2.14 atmospheres.
Yeah.
2.14? Is that blocked for you, or is it hard to read?
Yeah.
Oh, is that a glasses thing?
I've never had glasses. I probably should have glasses. You want to move that one? Oh, yeah.
You want to drag that desk to the middle here? We shouldn't be having you trade desks, but you can move it. There's no real reason that there's not a desk there. I don't know why there isn't. Just because. I want to then do or oh, you know, my glasses on, I can definitely do that.
I cannot. Oh, no, I can't.
I think I see a piece of your future, buddy. Increase the volume. So we'll just increase it to something. Sure, 673 liters because I picked something. So 18 is 673. So there, in case anybody online is a little lost. By what factor did the volume increase? Well, you put new over old. So 673 over 443. And it really was random, so I don't know what that number is going to be. Can someone punch it in? 1.51? 1.52, I'm told. I think Cameron keeps just chopping off instead of rounding off. How dare you? Sometimes I still kind of just as a joke give out nerd points. Oh, like you are a picky nerd after my own heart kind of thing. And many years ago, I said, I was at the board in the chem class at Southern School and said, I think some of you keep chopping off the number instead of rounding it. And this girl said, I hate that. And with this real tone, like she really meant it. Note the ending pressure, which was 1.41 for the people online, 1.41, 1.41. Is there something on the first page I should go back to, by the way? Because I'm going to flip the paper over. Oh, you know what, Luis? You know, now that I think of it, the thing that ends up making a lot of kids finally go, yep, I guess I got to get glasses, is you can't pass the seeing test at the DMV.
Oh.
That's where society is going to get you. They cover over one eye and you go, blurry shape, and they go, nope. Please don't drive without them, because you don't, you know, it's because what ends up happening is you end up staring at that sign for too long and you're not looking, you know, aware of other things. Okay, so what was the ratio of the pressure change? The new over old was 1.41 over 2.14. 1.41 over 2.14. Did I got that right? I'm just saying I didn't put old over new, right? I put new over old. Yeah. And so what does that end up being? 0.66 what?
Oh, 0.658.
5 to 3 digits just because we can. 5, what's after the 8? They said 5. Okay, round it off to 3 digits, 0.659. Okay. We see that if the temperature stayed the same as the volume, we said increased, right? The pressure decreased. And then guess what? Divide 1 by your answer to number 21. 1 over 0.659. I think some of you can hear this coming down the street with a brass band and a team of horses, but what are we going to get?
Uh, 1.52.
1.52, huh? And so partly that makes some kids remember, oh, I understand what inverse means now, but also, did changing the gas affect the outcomes, or did they work the same way? Did changing the gas affect the outcomes? No. And my point for all my math and science people is, use the bottom as a scratch paper again. Here's what you got when you have a normal kind of gas. You have a gas molecule, and then maybe a bigger gas molecule, and then another gas molecule, and a bigger gas molecule. And gases are so thin that the size of the molecule is not really the point. There's so much space between them that you can get the same kind of answer if you don't even take into account the size of them. And my metaphor is, we get 20 kids and line them up along the football field and blindfold them and say, I just threw out 10 random racket balls. Keep the blindfold on. You get $10 to find a racquetball in the next 2 minutes. Well, they go scrambling, right? And they're kicking around in the grass, and right? Okay, maybe somebody finds one. You put them back on the edge. You pick up all the racquetballs, and you throw out baseballs, which are bigger, and repeat the same thing. Do the odds realistically go up enough to bother with? Not really. There's so much space between them that the size is not really the point. Yeah, or softballs, right? I mean, if you go to beach balls, okay, maybe that matters, but even then, if it's only 10 in a whole football field, honestly, you might come out with the same kinds of answers.
Also, this is kind of the point. That's only in the far right and all of the far left.
Okay, we're gonna,
Take some time to like. walk
yeah. He's saying if they're randomly distributed, but they end up at one end because random is random. I know. And I was so my brother's wife's side of the family, I was over at their house and they said, "Oh, you put in uh, paving stones in the driveway." And they said, "Yes." There was a big discussion among the dad and son who were doing it. Does random mean that you accept random? Because random will give you clumps of certain colors of paving stone. So is it random and you'll accept the clumps, or do you want it to look random where you broke up the clumps and it's not really random? Because random has clumps. Well, they decided they didn't want clumps. But my point is just because something is clumped doesn't mean it's not random necessarily.
like the people who like try to make their hair look messy intentionally.
I want Nathan saying I want my hair to look messy intentionally, but not messy. I'll make it look all random, except that's too clumped and that's too far apart. I'll fix it. So how random was it?
Not really, so we have more of a choice.
Yeah, you put in a lot of choice, so it's not random. Okay, number 25, pick and note some beginning measurements. So I'm gonna go do that again. And heat it and let out some gas. Oh, well, they all disappeared. This is how random it is. That was a genuine mess up. We'll pump some in and then we'll decrease the volume. And something.
So put random buttons while your eyes closed. Not random buttons.
Okay, so what do we have? 510 liters, 460 Kelvin, and 6.66, how convenient, atmospheres.
Wow. I don't want to write that number.
Change the parameters in any way you like, and you know, I gotta go change this, except molecules, because it has been 3 years or something since I did this one, and I forgot. And in period 3, which is the first class of this for me, I changed the molecules, and then my math didn't work, made me look bad. So I got to go in. So don't change the molecules, and then we can change anything else. Well, if you when they say pressure, they mean pumping the molecules. So let's not do that. We can do it with this though, any way we want. Okay, and so colder or hotter? Hottie, colder or hotter? What do you think? What? Hotter? Okay, just to prove that I'm not choosing this.
Not corn or something, but
A coin to flip? Okay, so there's some stuff, right? Note the new measurements, 27, 488 liters, 340 Kelvin, 5.15 atmospheres. Take the original measurements, that's number 25, and multiply the pressure by the volume, then divide by the temperature. 6.66 atmospheres. $510 liters. Oh. And again, that was really random, and I even let a kid make a choice. So I did not do this before. I don't know what the answer is. Can someone help out? That's very quiet behind the mask. 7.38. Anybody else get that?
Yeah.
Okay. So 7.38, I'm told. 7.38. And then take the new measurements and do the same thing. I didn't really hear that. What?
I already did that one earlier.
Oh.
Once I didn't do like the first one, I did the second
We did the second one?
one. Yeah,
Well, don't spoil the reveal.
you know me, I probably missed a decimal or something, so.
A little bit, how much? Yeah, so not enough that it mattered, because all these values were rounded off by the computer, right? So, Nate, what did you get when you did this? You got 7.39. Okay, I can accept that. That's just because of the rounding off in these figures here. With the masks, I just can't understand it. You're gonna have to yell. You're gonna have to kind of yell.
460 for both.
Oh, I put it in wrong?
You put 460.
Yes. Thank you. This is 488. This is 340. There we go. Is that right? Okay, I'm pointing out my mistakes. Online people, sorry. This is 340. This is 340. I'm pointing here. This is 340. Oops. But look, how do these two answers compare? They're basically the same. And then, for all my lovable smarty pantses, and maybe you already sort of peeked at something, no, but this illustrates our next gas formula we will use. Can you think of how to write it? It's not a quiz. Just take a shot. What did we just prove? Can you think of how this would relate? We illustrated that something is equal to something, right? Nathan, you going to say it, or you have a different question?
I'm thinking that if I can try to say it, right? But we're gonna do volume base of molecules divided by what's the M? Molecules. No, that's not molecules. That's pressure. So yeah, when the volume times pressure divided by probably the temperature. Okay, except that's not an equation. You're halfway there. Probably, yeah. That's like
Well, but we showed that something is equal to something, huh? Didn't we? We just proved it. Also, without an inequality sign or an equal sign in the middle, we don't really have anything that helps, right? We don't have a statement that helps us figure anything out. So what we said is, and we proved just now, is the pressure from the first one times the volume from the first one over the temperature from the first one was equal to, when we did this from the second version, the pressure from the second one times the volume from the second one over the temperature from the second one. And we got the same answer. So if they're going to give you the same answer, they must be equal. Now, note to self, for all the actual science people who are going to end up in some college science classes, that's if you don't change the molecules. If you change the molecules, you messed it up. So P1 V1 over T1 equals P2 V2 over T2. Don't change the molecules. Or don't change the moles. That's only true if the moles don't change. Then, this is about the time I should say, should I repeat something or go back or make somebody think of a good question? It reminds me of that thing I thought about last year, or. If the temperature stays the same, what will happen to the value mathematically? Well, let's look at this. And this is one of these points has been, the two previous classes too, been a bit of a mathematical revelation for a few kids. So maybe that's you. On the other hand, maybe you think this is obvious, but I'm going to take the long way around because we've got the time today because I've proven it. In 7th grade pre-algebra or something, your teacher probably said, and then we multiply by T2 and that cancels out. And then we had to do the same thing to both sides. So we multiply by T2. And that's true. And that's fine. And that's why it works. What I'm saying is, I'm suggesting, how about this? I'm suggesting that we just say, this disappeared in the end, right? And it ended up diagonal. How about we just do that? And it's diagonal, there, I'm done. I mean, everything ended up being the same in the end. So why fiddle with all the middle? I'm not going to argue with correct answers. If you want to do all the canceling, you go ahead. But for all the people who get my point, it is going to save you time and so forth. And for all the college and all that. So maybe a note to self is for formulas that only have multiplying, dividing, and dividing, everything moves to the equal sign on a diagonal. If you only have multiplying and dividing, everything moves on a diagonal through the equal sign. So this can go here, that can go there, this can go here, that can go there. So that brings back this. If the temperature stays the same, what will happen to the value mathematically? Well, either this one will go up here, or this one will go up there, right? And once you get T over T, well, one way or the other, right? And here's my point. If they're the same number, what will happen to them? It'll equal 1. It'll cancel out to 1, won't it? And you'll have times 1 and divide by 1, but no one cares about times 1 and divide by 1. So it disappears. For all practical purposes, it's gone. You might as well just cross it out and be done with it. So if you know that it's the same, you can just do that.
So it's only just pressure and volume?
The same. Yes, at that point, if you know that the temperature is the same, you can just say, well, this was going to cancel out. Let's just skip it. And you don't have to know what it is. If they say, and the temperature is unchanged, you can say, oh, unchanged, you say, this equals this? I mean, I think that's what you just said.
So you literally don't have to do half.
You can just skip the temperature part, right? I don't have to know what it is. If you tell me that this is that, this is going to go up there, it'll cancel out. You know what? Why do I have to write all that? Skip.
It's like the cheeseburger stuff that we did earlier in the year, like times 2 something and divide by 2. It's like, not like 4 times divide.
Yeah. Right. Nathan's talking about when we did stoichiometry and we had 2 over 2, we just skip it. So the same thing goes for volume. If the volumes are equal, you know where this one would end up? Down here. And don't you have something over itself again? So you could just cross it out to begin with. So if some, what?
So what would you do?
Well, I'm saying pretend that, let's put the t's back in. So if you had, they said, and the volume is unchanged. Okay, so this will end up down here, or that one will end up down here. They'll cancel out in the end, so just cross them out to begin with. So if one of these is unchanged in this formula, it will end up canceling out. You might as well skip it. I mean, you can do it the hard way if you want. But the other confusion, unless I say this, is some kid will say, but I don't have a value. I don't know if it cancels out. It says it was the same. Does that count? Well, it's the same thing, right? Do you have to know what it is? I mean, my proof to that is I go, so what's that? And they say 1. Yeah, it is, right? Anything you could possibly conceive over itself is 1. What is this? I don't know. Is it the same as that one? I guess so. Do you know what it is? No. Do you care? It's going to cancel out to 1, right? I don't have to tell you what it is. So what will happen to the value mathematically if the temperature stays the same? It cancels out. What does this mean we can do with the temperature that doesn't change in the problems? Skip it. And when I see my handwriting this big, even on this screen, sometimes I go, yeah, I think my handwriting stopped developing in about 8th grade.
It honestly depends on how big you write though, because if I'm trying to like write really nice, I notice that my handwriting's a lot bigger. But then if I'm just trying to like write down notes really fast, a lot smaller and a lot sloppier.
If the pressures or volumes don't change, what can we do with the values?
Just cancel it out.
You just cancel them or skip them, right? They're going to cancel out. You might as well just skip them to begin with. So as a little bit of practice for that, a gas has a temperature of 14 degrees Celsius, a volume of 5.5 liters. Okay, another little helpful hint I would do until you get good at these, just a suggestion, is label these, because I've had kids say, it's so many numbers. Well, what's that? Temperature. Is it the first one? I guess so. And look, and if the temperature is raised to, oh, this is the second one, raised to, in our dumb little story is changed, right? So this is T1, that's T2.
And the volume doesn't change.
The pressure doesn't change, which means you can mentally cross out the pressure.
What would the pressure be for you to cross out?
Where would it be?
Yeah, you can cross it out. So like, it's not like all pressure.
Back in, I'm not quite sure what you mean.
No, I didn't know if it like mentioned pressure in the equation. Like the pressure is
Yeah.
how much.
Yeah, but we're gonna cross it out later. It's not gonna.
Yeah, I thought they put in like the little box, like the pressure is. I was reading it wrong. I thought I said that the pressure was like 5.5, and then it doesn't change. So I was just reading it wrong. So I just.
Oh. Okay, yeah, this is the volume, right?
Yep.
This is V1. And what is the question? Okay, so the question is, what's the new volume? And the pressure, well, we can do that, huh?
And
So-
then we would move the pressure and the volume over, so we would just divide.
Well, I'm saying actually do it. So what's the math setup using these values? And what can we do with P? And so what is the new volume?
Would we just put, well, it depends on.
Hmm?
Okay,
Go ahead.
could we just put the second volume on top of the first one? Because
They don't end up, oh, I'm sorry. We want to solve for V2, that's X. We need to get X alone and not on top of anything but one, because you said second on top of first or something. No, we want to isolate it, right? So I'm saying, how about we just write it in? Oh, the other wrinkle is, and probably somebody already started this, did you start using Celsius? Because you can't use Celsius. And Kelvin, whoops, Kelvin equals degrees Celsius plus, darn it, plus 273.
Okay.
And you can't use Celsius. And then some kid says, well, I use Celsius, but I did it the right way because I didn't use negative. You said the problem was negative and 0. You can't use Celsius at all. Because what we want is a ratio of temperatures. And look, this looks like if you use these numbers, the math will think, so to speak, that the heat went more than double. 29 is more than double of 14. But no, it didn't. Not really. That's why you had to use Kelvin, where the ratio is true. So we can't use 14 degrees Celsius. We have to use, where's my other paper?
would be 287.
287? And we can't use 29 Celsius, we have to use 302. So we get V1 is 5.5 liters over what's V2? I don't know. You get that.
It's because like, the pressure doesn't change, so I can't put it in there.
The pressure doesn't change, so there's no use in putting it in.
What I originally did, wrong, is I used Celsius and I also put the pressure, which was X. So
Oh.
it's X times liters equals X.
Yeah, pressure is not X, because what's the question?
Yeah, what it's like the volume.
What is the new volume? So that's X. Okay. In the nicest way possible, is there somebody who is saying, wait, how did that work? Can you tell me how to do that bit? Online or off? Well, remember we randomized all this data. I didn't do this last time. I really don't know what the answer is. Oh no, excuse me, this is not randomized. I do know what the answer is. If I can find my other paper, but can you make your calculator give you the right answer, which proves that you know how to punch it in? Because remember, when you're only multiplying and dividing, everything moves through the equal sign on a diagonal. So I don't personally actually write them in like that. I just say mentally, this is going to end up here. So I do 5.5 divided by 287 times 302, because 302 ends up on the top. And we get 5.79.
Yeah, I get that.
Liters, of course. Because the Kelvin cancel out. If you follow that this goes up there, then the Kelvins are over Kelvins and they cancel out. This also leads me, well, I'm going to do this anyway. We may not complete the front page of this, or the next page, or the next paper, but I'm going to do this anyway. There's no order of operations to multiplying and dividing. And here's my classic example. That's 1, isn't it? We can all agree it's 1. And so the 7th grade version is, okay, children, multiply by the top and get 12, multiply the bottom and get 12, and that's 1. Okay, there's no order of operations. Observe. 4 over 2 is 2, and that 2 lives up here. 2 times 3 is 6, and 6 over 6 is 1.
And then you just like, hold on, like cross it, so it's like 4 divided by 2.
That's what I did.
Divided by,
Oh, and you could say, or 4 divided by 2 is 2, 3 over 6 is a half. Sorry, is well, it's 1 over 2, and we end up with 2 over 2 is 1. Yep. Or 6 over 3 is a half. That half lives in the top. Half of 4 is 2. 2 over 2 is 1. Or you want to get really fancy pants? 3 over 2 is 1 and a half. 1 and a half of 4, and I'll slow down here, is 1 of 4, which is 4, and a half of 4, which is 2, which means you have a 4 and a 2 added, not multiplied, together is 6. 6 over 6 is 1. It doesn't matter how you do it. And then how about we go to this then? For the rest of the class then. Oh, I do have one more math trick. Actually, it doesn't come up on the front page, I've learned, but this is one of my favorite math tricks. Or you can do T1 over P1 V1 equals T2 over P2 V2. If you flip both sides, it's still fair. And this comes in handy when they ask you to solve for temperature. I can tell you from many experience that it's easier just to flip both sides. When you have to solve for T in the bottom, it gets so messy that I have messed that up and I teach the dumb class. So I flip both sides when I'm going to solve for T. So what's one? Self-test. Can you do one? And I'll do it. So if you need to peek at my writing, it's not a quiz. You can watch me. But also, can you do it? So I'm going to cover over the answer. You want to take a peek at the setup? Did you get the setup? Does anybody else want a forward of the bus times? Who is that in your profile, Luis?
I have no idea.
It doesn't look like you.
It's not.
It's a very tiny picture, but
Yeah.
the wrong
Yeah, let's-
age, size, race.
Yeah, let's just take some insight to it.
Oh, okay. Okay, well, I forwarded you this email because, yeah.
All right, thank you very much.
So,
And Mr. Sweeney, I did like the right, way like writing it down originally, but I didn't like solve it correctly.
okay, so you agree with the setup, but then the answer went off? Okay, so what did you do? Can you narrate what you typed in?
So, cross multiplication isn't one of my strong suits. I tried that just so I can get better at it.
It's kind of that, but what did you type in?
So, first off, I did 10 times 24,
10 times 24
and that was 240
Yep.
over 200.
divided by that,
Okay, yeah.
right? Is that what you're saying?
No, so I was doing the cross multiplication.
Oh, so this times that, and then what?
So then I had 240 over 200.
Yeah.
And then I had 14 x, just because
Sure. Sure,
over
14x over 300.
And then I did the 200 times the 14x, and then the
Ooh,
40 times the 300, and I add those.
and then you multiplied this down here and you multiplied that up there.
Yeah.
You can do it that way. So I'm a little surprised you got the, so we end up with this times that, right? Over this times that, right?
Nope, I didn't put it over each other. That-
The 14 travels down here.
Yeah, so it'd be, what is it, 3,360 over 540.
I didn't stop in the middle. I don't know.
Okay, hold on, let me see if I get that same answer. Because then I got always like six repeating.
Okay, so we did, in practical terms in the calculator, you did this times this and then times that?
Yes.
And that was some number, fine, right?
Yes,
And then you did this what? Times
yes,
that?
times the 14.
Okay, okay. When you did 200 times 14, where did you write that answer?
Originally, I did both those answers together, which that's why I got such a,
You added them?
yeah.
You
Again,
buddy.
it's been like a hot minute, so I've done like cross multiplication.
Okay.
I've always done it a different way, but
All right. There's no adding in this.
yeah, I just do my mistake now.
Okay. So here's how I think about it anyway. I said everything is going to travel diagonally, and I got to get V2 by itself. This is going to go up there, and this is going to go down there. Now I've got to move diagonally, and now they're not here anymore.
Okay, so then it's like big one giant equation, which would be 10.
You can write it out again. I'm just saying maybe you can get to the point where you don't write it out again. Oh, here's my calculator. Okay. So here we go, trying to get this visible. I got the same thing as last time. So thank you for speaking up, Nathan. That, finding out what's going wrong is part of the process. Anybody else got a thing going on? Nathan, does that return to you 25.7?
Hold on.
Oh,
I don't know why that's not working right now.
I think I have a suggestion in a minute too. Because I realized that a lot of kids got sort of hand-holding math in 6th grade, 7th grade, even 8th grade. And when I see them writing down way more than me, I say, oh, they're still doing sort of 7th grade pre-algebra in their heads. And I'm saying there's a faster way.
Okay, got it.
Okay. And just as a suggestion, just trying to be helpful, you did a lot more writing than I did. What I'm saying is, if you know that this is going to go down here, and we know this is going to go up there, just do 10 times 24 times 300. That's the top. I don't stop though, is my point, okay? Divided by 200. Does that work for you as a concept so far? And here's the point that I found out some very bright kids have never had somebody say, hey, look, when I do this times this times this, just follow along for a moment, just watch. These three are going to get multiplied, yes?
Yes, yeah.
Divided by 200, and that answer lives up top. Whatever that answer is, it's up here. And so it is divided by the thing that remains in the bottom. And so I can say this times this times this, divided by 200, divided by 14, and I haven't cheated. When you take a dividing answer, that answer lives in the numerator. Did it work?
Yeah, actually.
Yeah.
Yeah, I was doing it where I did not push equals until I got something else. So I did 10 times 24 times 300.
Yes, these three. And then
I got like 720.
I didn't hit equals, but go ahead. You can.
And then like divided by 2.
Divided by 200.
Times 14. Which then is like 200 times 14, which is a bigger number. And then
Did you do divided by 200 parentheses times 14? Or did you
200 times 14.
see? Then the calculator is going, what the calculator's, you got the wrong answer, correct?
Yes.
Okay, because here's what the calculator did. This times this times this, which is correct. Divided by 200, which is correct. But then that answer really lives in the numerator and is divided by 14, but it read you telling it, take that answer and multiply it by 14. No, it's not. It's over 14. So if you're not going to use parentheses, that's wrong. That's why I like my way. You don't have to do it, but I find out I can convince like 80, 90% of the kids to do it my way and it's faster.
It is a lot, actually. And also, when it comes to writing stuff down, I just write stuff down because I can't visualize those things.
Okay.
So like, the whole like arrows switching over, it's kind of hard for me to like understand that. So I just write everything down that have it reset.
Okay.
Just because remember you saying like kids write down more than you think
It's not I don't argue with correct answers. On number 2, though, hey, there's another couple notes we should take. I know I said this before, but 1 millimeter of mercury is 1 torr, and 760 torr is 1 atmosphere. Because in number 2, they give me atmospheres and millimeters of mercury, and you can't use both at the same time.
So you need to convert
You got to convert something,
from mercury to
or you could convert it the other way. I was going to convert millimeters of mercury to atmospheres, but it doesn't actually matter. As long as everything's in yards, all your math works. As long as everything's in feet, your math works, kind of thing, right? Which one do you need? I don't know, but not both at the same time. Does that work? So I'm going to do this. 1 atmosphere for every 760 torr. And remember, a torr is a millimeter of mercury. So that's not a contradiction. This really does cancel out like that. And I got 1.38 atmospheres. It's 1 standard Earth atmosphere at sea level on a normal day, whatever that is. The physics people don't really like that because, and I think I was saying this before. Oh, somebody asked me kilopascals. Did anybody, was that this class?
I think it was probably Kristen's.
It probably was. Kilopascals work with stuff like joules and watts and stuff that has kilograms and meters and seconds in it. So, but the chemists usually aren't figuring out like that kind of problem. So this is a bit of a cheat, but it's a cheat that works. So sure. So can you assemble number 1? Well, the first pressure was 3.3 atmospheres. The first volume was 15 liters. The first temperature was 299 Kelvin. Then things changed. The second temperature was 350 Kelvin. And since I converted this, the second pressure was 1.38 atmospheres. What's the new volume? I don't know. And then it becomes the whole diagonal multiply divide thing. And 2 years ago, I had a very bright girl who was actually tutoring that corner of the room kind of thing. And she went, oh, when I said, remember, when you multiply and then divide, that answer lives on top. And it is divided yet again by the thing that was on the bottom. And no one had said it in those words, to her. And because she was doing the same thing, she was multiplying by the thing on the bottom and getting the wrong answer. So I got last time 41.9 liters for V2. You got the same? Good. You say you didn't?
Yeah.
Yeah, see, I know. I think this class ends up sort of catching kids who got a little glassy-eyed when the math classes keep saying, but this is why, but this is why, but this is why. And I'm not saying those, I genuinely, seriously, do respect those math ladies in trying to get the, but this is why things work. But also sometimes just get the job done, is what I kind of feel like doing. And also, I figure there's 10 to 20% of kids who are just sick of why and just tell me what to do. Okay, diagonal, there you go. And maybe I can punch through 3. I don't know if you can follow, but let's see. Oh, that can't be 65 Celsius. I mean, that's got to turn into 338 Kelvin. I'm cheating because I did this before, so it's not that I'm doing this in my head. I did it before. So now I have a first, what was the original pressure? The original pressure is, I don't know. What was P1? Don't know. The first volume was, 28 liters. The first temperature was 338 Kelvin. And the second temperature was 308 Kelvin. And the second volume was 36 liters. And the pressure after the change was 2 atmospheres. And so it's not a big wrinkle, but the tiny, tiny wrinkle is it's going the other direction. And when the first year I was here, I had a kid in physics who was not very mathy. And I didn't want to solve for one side, so I turned the whole thing around. I just swapped left side to right side. And he said, wait. I had to stare at it. But it doesn't matter which side is the left side and the right side, does it? Not really. And I got, just to skip ahead, 2.82 atmospheres. I think that's right, because 2 other classes said it was right.
Okay, yeah, that's right. Hey, you just switch them up. Yeah, actually, all makes sense.
These people. Skipping a long story. Oh, can we make an appointment with you, knowing that you're a teacher, for the middle of a morning on a school day? Yeah, that's going to work real great. What did you think? Anyway, I have the other solutions. I will go post them the front now, and then I'll solve the back and post those too. And I think we're out.